Welcome back to Jennifer Chemistry Official, where we make chemistry friendly to all our learners. Today I want us to look at this subtopic that is one requirement when you're writing chemical equations, because when you are told to write well-balanced chemical equations, there is this one requirement where you must write the state symbols. So without this knowledge of the solubility of salts, there is no way that any given student will be in a position to write correct equations. So we usually have four state symbols. We have those that are in the aqueous state. We have others that are in the solid state, others that are in the liquid state, and others that are in the gaseous state. Those that are in the aqueous state, we usually write a small a and a small q into bracket. Those that are in the solid state, we usually write a small s into bracket. Those that are in the liquid state, we usually write a small l into bracket. And those that are in the gaseous state, we usually write a small g into bracket. So let us begin together with the mnemonic. We have neat girls, always clean and polish, shiny, plastic, but colorful cups, innovative free. So for neat, we have nitrates. All nitrates are soluble. All of them are in the aqueous state. And the aqueous state, we have a small a and a small q into bracket. For girls, we have group 1 salts, and all of them again, they are all soluble in the aqueous state. Again, small a, small q into bracket. Always studying in for ammonium salts. All ammonium salts are soluble. Again, they're in the aqueous state, in the a, small q into bracket. Clean, studying in for chlorides. All chlorides are soluble. All of them are soluble, that is in the aqueous state, small a, small q into bracket, except. So the ones that follow on are those that are insoluble, though they are also chlorides. So down there we have and polish. I have circled them because they are examples of chlorides. So and the A standing in for Ag, which is silver. So silver chloride is insoluble. And the state symbol is a small s into bracket. Polish standing in for Pb, capital P, small b, that is red. And lead 2 chloride is also insoluble, just like the silver chloride. And it is also in the solid state, a small s into bracket. Let me give this NB at this moment. All those salts that are insoluble, they are usually observed as precipitates in case of a practical. So then we move on to shiny. Shiny standing in for sulfates. All sulfates are soluble in the aqueous state, a small a and a small q into bracket. Again, we have 3 exceptions. The first one is plastic, standing in for Pb, capital P, small b, standing in for lead 2 sulfate, which is insoluble. The state symbol is a small s into bracket. But standing in for barium, barium sulfate is also insoluble in the state symbol of small s into bracket. Colorful, standing in for calcium, calcium sulfate is slightly or sparingly soluble. So the state symbol for calcium sulfate is usually 2 small s into bracket, meaning slightly soluble, or sparingly soluble, meaning only a part of the calcium sulfate will be soluble. while the bigger percentage will be insoluble. That is why we will still see a part of it being a precipitate. So for lead 2 sulfate and barium sulfate, they are also seen as precipitates. Caps standing in for carbonates, innovative-free standing in for insoluble. So all carbonates are insoluble. Again, those that are insoluble, we put a small s into bracket. Again, in this case, we have exceptions, and the exceptions for this case, we have the carbonates for group 1 metals, the likes of lithium carbonate, the likes of sodium carbonate, the likes of potassium carbonate. All of them are soluble. Just like we began, where we have girls, we say that all group 1 salts are soluble. So even for carbonates, as long as they involve the group 1 metals, they are also soluble. Again, we have ammonium carbonate, which is also a soluble. And those that are soluble, remember we put them in the aqueous state, a small a and a small q into bracket. This is one area that is very, very important for you as a student, because anytime you are told to write a well-balanced chemical equation, in the balancing, there are those requirements. And the first one is, in a well-balanced chemical equation, you must use correct chemical symbols. Once you use the correct chemical symbols, you then balance it. And once you balance it, you should also check on the state symbols. So if you omit the state symbols that comes from this subtopic of the solubility of salts, just be sure that your equation will not be marked correct. So there must be correct chemical symbols, followed by being well balanced, and again with the correct state symbols. And just to remind you, we have 4 state symbols. Let me remind you of something. When you entered Form 1 as a student, you are taught about the 3 states of matter. The 3 states of matter are solid, liquid, and gases. From all the 3 states of matter, we get 3 state symbols. From the solids, we get a small s into bracket. From the liquids, we get a small l into bracket. And from the gases, we get a small g into bracket. And then for the aqueous, this comes in anytime you mix a solid and a liquid. For example, you take a certain solid, a certain salt, for example, you put it in water and it dissolves completely, then you end up with the aqueous state. So let me also remind you of animals that live in the water. We call them aquatic animals, like the fish and others. So from the word aquatic, we have aqua. Aqua has something to do with water. And so when you hear of the aqueous state, those are the salts that usually dissolves completely in water. Those that fails to dissolve completely in the water, those are the ones that we say are insoluble. They are insoluble. And in our next lesson, I will also be showing you that salts cannot only be insoluble in water, but they can also be insoluble when you mix 2 types of salts. When you mix 2 types of salts, 2 soluble salts, and then the product that they give one of the salts being soluble and another one being insoluble. That actually will take us to our next subtopic, where we'll be having ionic equations. Because when you're forming ionic equations, you just use 2 soluble salts, and when they exchange their non-metallic part or their radicals. If radicals are involved, when they exchange the radicals, we in the product part get two salts, one which is soluble and another one that is insoluble. So I'll be showing you more on the same. So you can either have a substance being insoluble in water, or you mix two soluble salts, one of them in the product side becomes soluble and the other one insoluble. So you see, you still be involving the states of matter and also the state symbols in general, because other than the three states of matter, we also add the aqueous, which is the fourth state symbol. In case you have any question, feel free to ask it in the comment section. I'll be guiding you on more of this, and especially in the writing of chemical equations, and in addition the writing of ionic equations. So keep it right here. This is where chemistry is made very friendly to you as a student. So again, remember, anytime we have a lesson, you must always have your notebook. Write good notes. You require them not just now, but even in the near future. So remember the mnemonic. For solubility of salts, we have neat girls, always clean and polish, shiny plastic but colorful cups, innovative free. So who would not want to become like these neat girls? And by just knowing the mnemonic, you're able to remember all of them. If you're new here, kindly subscribe. Press the subscription button. It is very free. Like, share, and comment. Let me know which is this other topic or subtopic that is troubling you. I'm right here, just a comment away from you. I wish you the best. Remember, hard work pays. And very soon, if you keep it right here, it will pay. I wish you the very best. Thank you.